A single speck of light can hold the secret to a star's death, and some of these dots are on the very edge of collapse. Stay tuned, because the first one is a mystery even seasoned astronomers struggle to explain. Imagine a tiny, infrared bright speck hidden deep within the spiral arms of galaxy NGC 1234, barely visible even to powerful telescopes. This dot emits a spectrum that suggests a temperature far higher than surrounding dust, hinting at a compact object heating its surroundings. Researchers propose it could be a massive star in its final nuclear burning stage, where iron core collapse is imminent. If the core succumbs, it may form a black hole without a supernova, a failed supernova scenario that's still debated. Observations over several years show a gradual dimming, consistent with material being swallowed by an event horizon. While the exact mass remains uncertain, models estimate it to be around 25 to 30 solar masses, placing it near the theoretical threshold for direct collapse. This makes the infrared dot a prime laboratory for studying how massive stars end their lives silently, reshaping our expectations of stellar death.
Consider the faint, radio-quiet point discovered near the center of the Perseus cluster, a region dominated by hot gas and galaxy interactions. Unlike typical radio sources, this dot emits almost exclusively in X-rays, suggesting an accreting compact object without powerful jets. Some scientists think it could be a neutron star on the brink of collapsing into a black hole after accreting matter from a nearby companion. The X-ray luminosity fluctuates on timescales of weeks, a behavior that matches theoretical predictions for a star nearing its Chandrasekhar limit. Spectral analysis indicates heavy elements like iron and nickel, which are usually expelled in supernovae, yet they remain bound, implying a collapse that avoids a dramatic explosion. If confirmed, this object would provide a rare glimpse of a star transitioning directly to a black hole, challenging the conventional view that most massive stars explode before becoming singularities.
Astronomers have catalogued an optical flicker in a remote region of the large Magellanic cloud that behaves unlike any known variable star. The source brightens and dims irregularly over days, with a peak luminosity that rivals that of a typical red supergiant. However, its spectrum shows unusually strong helium lines, a sign that the star has already shed its outer hydrogen envelope. The prevailing hypothesis is that this is a massive Wolf-Rayet star that has exhausted its nuclear fuel and is teetering on the edge of core collapse. Models suggest its mass could be as high as 40 solar masses, placing it in the regime where a direct collapse to a black hole is plausible. The erratic flickering may be caused by unstable mass loss episodes, a prelude to the star's final implosion. Monitoring this dot could capture the moments before a silent birth of a black hole.
Hidden deep within the spiral arm of galaxy M81 lies a compact ultraviolet spot that emits more energy than a typical star cluster of its size. The UV excess indicates a hot, dense object, possibly a massive star whose core has entered the final stages of nuclear burning. Spectroscopic data reveal a deficit of hydrogen and an abundance of heavier elements, suggesting the star has undergone extensive fusion cycles. Researchers estimate the object's mass to be around 20 to 25 solar masses, which theoretical models classify as borderline for a direct collapse. If the core collapses without a supernova, the resulting black hole would be formed quietly, leaving little trace in the surrounding medium. This hidden spot offers a rare opportunity to study a pre-collapse star in a relatively isolated environment, free from the confusion of crowded stellar neighborhoods.
Surprisingly, a faint gamma-ray glimmer has been detected a few light-years from the Milky Way's central black hole, an area dominated by intense radiation fields. The emission is sporadic and low energy, unlike typical gamma-ray bursts, leading scientists to suspect a massive star undergoing rapid core contraction. Theoretical work suggests that a star of roughly 30 solar masses, stripped of its outer layers by tidal forces, could emit brief gamma-ray flashes as its core density spikes. If the star's core surpasses the Tolman-Oppenheimer-Fokoff limit, it may collapse directly into a black hole, contributing to the dense population of compact objects near the galactic nucleus. While the exact mechanism remains under investigation, the glimmer provides a tantalizing clue that stellar deaths can occur even in the most extreme gravitational environments.
Rarely does a dust-obscured dot emerge from the thick clouds of the Orion Nebula with such striking infrared brightness. The object is invisible in optical wavelengths but shines brightly at 10 microns, indicating a hot core enshrouded by dense material. Its spectral energy distribution matches that of a massive protostar that has already ignited nuclear fusion but is quickly exhausting its fuel. Estimates place its mass near 35 solar masses, a regime where theoretical models predict a direct collapse into a black hole after the core runs out of nuclear fuel. The surrounding dust may conceal a nascent supernova that never fully develops, making the dot an early indicator of a silent stellar death. Ongoing observations aim to track its luminosity decline, which could confirm the collapse scenario.
Few people know that a modest X-ray flicker in the small Magellanic cloud has sparked intense debate among astrophysicists. The source exhibits irregular outbursts lasting a few hours, with a peak luminosity comparable to that of a bright X-ray binary. However, the absence of a detectable companion star suggests the flicker originates from a solitary massive object. One leading theory proposes it is a massive star whose core has entered the perinstability regime, causing rapid pulsations before a catastrophic collapse. If the star's mass lies between 140 and 260 solar masses, it could undergo a perinstability supernova, but recent models indicate a fallback collapse may instead form a massive black hole. The flicker's erratic behavior may be the star's final throes, offering a rare observational window into these extreme processes.
Deep in the luminous Eagle galaxy, a submillimeter spot shines with a brightness that defies expectations for its modest size. The emission peaks at wavelengths around 850 microns, typical of cold dust heated by an intense, localized energy source. Spectral analysis points to a massive star undergoing rapid core contraction, likely in the final stages before collapse. Models suggest the star's mass could be close to 28 solar masses, placing it near the threshold where direct black hole formation is feasible. The surrounding region shows little evidence of a supernova shockwave, supporting the notion of a failed supernova. Monitoring this spot over months has revealed a slow decline in submillimeter flux, consistent with material being swallowed by an emerging event horizon. This object provides a compelling case study of how massive stars can disappear silently, reshaping the interstellar medium without dramatic fireworks.
Finally, a transient light echo captured in the outskirts of the Virgo cluster hints at a star that may have collapsed without a traditional explosion. The echo, a faint, expanding ring of reflected light, was first noticed in archival images and later confirmed with deep exposures. Its spectrum lacks the broad emission lines typical of supernova remnants, instead showing narrow absorption features indicative of a cooler, dense medium. Some astronomers argue the echo could be the lingering glow from a star that underwent a direct collapse, where most of the energy is trapped inside the newly formed black hole, leaving only a subtle flash to illuminate surrounding dust. If this interpretation holds, the echo represents one of the few observable signatures of a silent stellar death, offering a new method to identify such events across cosmic distances.
In Andromeda's outer halo, a compact region of radio silence has drawn attention as a potential sign of a star on the brink of collapse. While most massive stars emit strong radio waves during late-stage stellar winds, this point shows an unexpected drop in radio flux despite strong infrared and X-ray signatures. The discrepancy suggests that the star's outer layers have been stripped away, and the core is collapsing so quickly that there's insufficient time for wind-driven radio emission. Estimates based on the X-ray luminosity place the star's mass near 32 solar masses, aligning with theoretical predictions for direct black hole formation. The radio silence may be the final quiet before the event horizon forms, making this dot a subtle yet powerful clue about how some of the universe's most massive stars meet their end without a bang.
We've traveled through 10 faint, enigmatic points that might be the universe's earliest collapsing stars, each offering a glimpse into the violent transformations that shape galaxies. If you found this journey into cosmic uncertainty fascinating, subscribe so you won't miss the next mind-blowing list we release each week. Which dot surprised you most, and why? Let me know in the comments below, and if you enjoyed the video, give it a like to support the channel. Thanks for watching, and keep looking up.